Let me start first talking about the course profile. Okay, soon it will be uploaded after we got the approval from the quality assurance office. And this course, let me tell you the story of this course before I start talking about course profile. This course is the first course for renewable energy in Oman. It was started in 2007. We started this in 2007, and maybe a couple of years later, Dhofar University started similar course. Another few years later, Sultan Qaboos University started, and then in maybe 2012, I was one of the committee who recommend for the ministry to have similar course for the technical college in 16 technical colleges in Oman. So it's become part of the engineering, let me say, streams because it's importance. And I will talk about the importance of why we need to study renewable and sustainable energy, and particularly in level 4 later on. But this is the story from where this course came. And this course this year will be for electrical and chemical. In the past was for 4 streams, and because they changed their program, it has been changed. Now the course is related to renewable energy. Definitely, when we talk about renewable, we need to mention to non-renewable for seeking comparison and to highlight the advantages, barriers, technology, resources, and so. And also we will focus on the sustainability because part of your task as an engineer, regardless your specialty. Now, in this course, the objective of this course is, I will read it from this slide here, provide the students with fundamental of renewable and sustainable energy, introduce renewable and sustainable energy system life cycle analysis and principles of operation, familiarize students with energy sustainability, matrices, energy conservation, optimization, sustainability, and business, energy storage and management. And based on these objectives, I can put my course learning outcome into 4 points. These are the 4 points, what we are going to discuss through the semester, what we are going to do through the semester. We want to meet these objectives, these course learning outcomes. The first one is analyze qualitative and quantitative analytical skill on energy system and engineering design. And the second one, to calculate energy system performance and identify sustainable development and their application in engineering projects. I hope when I'm reading now, you compare this with what you are studying, if you are chemical or electrical. Design sustainable engineering solution to engineering problems, and describe fundamental principles associated with the energy system and evaluate their applications in engineering design and sustainable development. These are our 4 objectives. Now, we have 4 modules, so we are going to link each one of these course learning outcome to one of our modules. We will discuss each one of them in 3 weeks. We will have for assessment tool, we will have assessment 1, which is test, okay, midterm, let me say. It will be in week number 9. The weightage for this one is 30%. It will cover course learning outcome, the just I mentioned, 1 and 2 and 3. And for the second assessment, it will be lab report. Lab report, you are going to distribute it in groups. You will work with Miss Mose. The materials are already uploaded there. We will upload a video to show you how we do the experiment inside the lab, and then we need to prepare your report, your discussion, your analysis, okay? Miss Mose will be in touch with you in this regard. These are the 50 marks and the 50 marks for final. I'm just trying to give a brief here about the course profile. You see here, this is our schedule. We started this week, 24th January. This is module 1. This is the title of module 1, which is renewable energy and solar radiation. And these are the 3 weeks, let me say, topics to be covered. Module 2, we will talk about photovoltaic and solar thermal, and in 3 weeks we will cover these topics. Module 4, wind, hydro, electric energy, we will cover them in 3 weeks. And model for biomass, geothermal, and energy conservation, we will cover these in 3 weeks. Then we will have 2 weeks revision to prepare for the final exam, which will be on 9th May. Okay. Here I try to mention some of the textbooks. It's available. I can provide some of them for you through my page in Microsoft Team. So this is in general the course profile. Okay. صوتي ده يوصلكم. You can hear me, right?
We hear you, Doctor. We hear you.
Great. Okay. Today is introduction. I will give introduction to the topic, but let me start the slide here. You see the slide? Can you see the slide?
Yes.
Great. Now, module 1, the 3 weeks, this is week 1, okay? We have 2 hours. This is the first hour and the second hour later on, inshallah, this week. The title for this module is renewable energy and solar radiation. We will study these 2 points. But today, I will start with renewable and non-renewable energy. I will split it in 2 parts. The first part is just giving general overview. And the second part is I will start, let me say, give a brief on each one of renewable energy sources and technology, and try to make a comparison with the global situation, Oman and a global situation. So today is just introduction, which is related to the first course learning outcome. So this is here, renewable and non-renewable energy. I will talk about the principle classification energy. Before I start this, I would like to mention 2 important questions here. Is you may ask why we need to study a level 4. We are chemical, we are electrical. Why we need to study energy, renewable energy? Why we need to study sustainability? Now, the answer for this question is, you know that humankind facing 3 important challenges. These are water, food, and energy. Okay? These are the main targeted for humankind today. Water, food, and energy. Our work is, by the way, they are connected, as I will show you later on in sustainability, but we focus on energy here. It's not enough to design engineering system. If it is chemical system, electrical system, whatever the specialty system, but it is not enough. We need to consider the consumption, the energy usage and the consumption. We need to consider the efficiency and all these related to energy. We need to consider the cost related to energy. This is one. The other issue is today the energy demand everywhere in the world increased because of the lifestyle change, because of the industry everywhere. Okay, so more needed for energy is there everywhere in the world, in any country. And since energy cost is high, we need to consider it, we need to conserve it, we need to reduce the consumption, we need to provide the energy needed. It's not easy. Some countries, as I will show you in the sustainability part, some countries are failed to provide electricity, as example, which is something simple and necessary today for more than, let me say, 70 or 80% of their population, which is not good. For that, in this level, we focus on energy, so you can consider it when you graduate and work anywhere in the world. You will consider energy in your system, in your design, in your problem solving, and so on. And the same thing for sustainability, as I will explain later on. Now, if I would like to show the energy sources, I will say energy sources could be solar. I'm talking about renewable energy mainly here. Geothermal, tide, nuclear. I will give a brief later on this week, inshallah. And some of them more classified. As example, solar could be direct energy, storage energy, indirect. Solar energy could be photovoltaic, thermal, hot water, hot air, and so on. You can see, I don't want to read from the slide. We will study all of them, almost all of them, okay? But this slide, this classification, I can highlight a few points here. The first point, I have variety of energy sources, right? Wind, hydro, otic, solar, biomass, and so on. So I have variety of sources of energy, and this lead to variety of technology, and then the variety appear in the profile, energy profile. Okay, and the second issue is it seems to be we can convert this energy from one shape into another. This is good. I mean, as example, in the electricity you have at home, you can't convert it into light. You have fluorescent lamp. You can't convert electricity into light. You can't convert it into heat by heater, and so on. So we can convert it from one shape into another. Still, introduction to the topic. So when we talk about definition for energy, we know that if we have car, the gallon of petrol inside the car tank, okay, it represents potential source of energy. It's energy saved when we burn it in the engine, we drive the car, then we change it to another type of let me say energy shape. As example, I burn the fuel, the fossil fuel, it become heat, and the heat, let me say, moving the piston inside the cylinder, and then crankshaft, and then wheels, then we drive the car, then we have mechanical energy now. So potential energy is there in our nature, let's use it. Okay, now which at the end will produce mechanical work, this moving and motion there. So we can represent the power from principles in secondary school. You remember power is dW over dt, the differentiation of energy with respect to time, or let me say energy is integration of power with respect to time. Okay, this is for the definition. I'm trying to remind you what you already study in secondary school regarding energy and work and power. Okay, power is the, as I mentioned, rate of change of work with respect to, or energy with respect to time. Now energy could be small values, medium values, large values. We are going to see that sometimes we deal with system which produce or consume small amount of energy, and sometimes with medium or sometimes with large. As example here, when we talk about power plant, in Sohar there is 1000 megawatt power plant. This is high or a huge amount of energy. But when we're talking about small battery, we're talking about small amount of energy. Based on this, we will see that we are going to deal with large numbers and small numbers. Also, from the other side, you can see in this table, I just show here this table, it seems to be that energy have different units. It can be measured in different units. As example here, kilojoule, kilocalorie, kilowatt hour, equivalent. سكر المايك سكر المايك. Okay, kilogram oil equivalent, natural gas. Okay, and here you can convert from one into other. As example, 1 kilojoule here, as you can see here, this is 1 kilojoule could converted equivalent to 0.2388 kilocalorie, or equivalent to 0.00024 kilogram oil equivalent, and so on. So we can convert from one way into another. You can read more in these resources. I just here try to give you. I know that you like to read from your mobile phone, so just click on these links. You'll find more information. Also here, another table which is useful also, using international system units. As you can see here, we have more units: BTU, British Thermal Unit, KPM, kilopound meter, or they call it kilogram force meter, ERG, or electron volt. Electron volt, we'll see, this is when we talk about the level of electrons. Okay, small, let me say, energy amount for electrons level. And based on this, we need to know how to deal with the prefix. Some high values, some low values. سكروا المايك لو سمحتوا.
يقول الأستاذ دهنود بسرعة أمي يصوت لي.
سكروا المايك يا شباب يا بنات، سكروا المايك. Please close your mic. Okay. Okay, thank you. So we will see that we will use kilo, or 3 to power 10 to power 3 zeros, it means mega, giga, tera, and so on. We need to know the power for these, let me say, prefix. Also for small values, milli, micro, nano, and so on, we need to know their values, because we are going to deal either with large values or small values. You know this, you study this in different level in engineering. Now, when we talk about renewable energy, we need to look to the, by the way, let me just tell you something. We as an engineer, usually we deal with some criteria or indexes to judge our systems. As example, efficiency. Usually we judge our system by efficiency. As example, when we say efficiency is high, the system is good, okay? When efficiency is low, the system is not good. 90% efficiency is good system because the output over input is high. And when it is low, as example 20, 25, this is not good system because the output over input is low. And this happened because the output is input minus losses, okay? So when the losses increase, the efficiency reduces because the output reduce. Now, this is telling me that when the losses increase and efficiency reduced, the cost increase because I will pay for the losses, which is something not useful for me. Okay, so we judge our system by using the efficiency mainly as an engineer. In renewable energy, this is not enough to judge the system by efficiency. I mean, efficiency is not enough to judge the system. Sometimes we may deal with system have efficiency 3 or 4%, but is effective, okay? So in renewable energy, efficiency is not enough to judge our systems. We need to look to the cost also from the other side, okay? As I will give example here, and I will go through the few examples later on today, inshallah. Now, have a look. This is paper published long time ago in Europe, and it's talking about installing system which is 2.2 kilowatts, small system. And at that time, the incentive for, I mean, when they sell the electricity to the network, to the utility, they pay 0.087 euro per kilowatt. Okay, so the author, what he did, he multiplied the rating, the installed power by the cost, by the power per cost per power. It gives him the total cost is 0.19 euro. It tells him that this system, the power cost by this system is 0.19 euro. It's, so you may ask this question, okay, it's a very small amount, so I will pay here for the system maybe 4,000 or 5,000 at that time, just to take 0.19 euro part of the euro. And this is wrong. We need to look to the long term. I mean, to the energy, how we produce, how much we produce, and for long term. So if I come to say that I am producing 1,000 for the same system, 1,650 kilowatt hour per year, and I multiply by this value, which is 0.0287 euro. So it tells me that yearly I will get 143.55 euro. You see? So always we need to consider the cost. It's not enough to consider the efficiency. Cost is also important element to be considered here. Now you remember from secondary school the law of energy conservation, where it say that the energy content of an isolated system remain constant, energy cannot be created, not destroyed, and it's not the full story and the full truth. And there are some, let me say, important elements here is not clarified yet by scientists until today. I mean, we cannot say it cannot be destroyed, nor, I mean, this is like absolute, okay? And always we will be in a cycle. Now you told me in your previous example, I'm talking with myself now here. You told me that I have a gallon of petrol. I burn it inside the combustion engine of the car. It's converted into heat, and then heat converted into mechanical energy and so on. Petrol came from where? You will say it come from this part. And this part coming from where? Another part, another part. You'll be in cycle. What is the first point we started with? Where this energy will go on at the end? So this is make a cycle. Besides, when we define energy and we say its ability to do work, ability is something like feeling, motion. So this is not enough explaining something physical, and we can't feel it, we can't deal with it. Okay, so I cannot depend on these type of definitions. There are many definitions for the energy, but I'm still not, I mean, I have my definition, but I'm not convincing with these, but just to highlight. Now, I talk about the car. You know, solar cell. We will talk about solar cell, or let me say photovoltaic, we call it also. Okay, we will spend our time there, we will enjoy. But solar cell, what it happened, we receive light, we convert into electricity. Okay, this is what happened. We cannot say solar cell is producing. It's not producing electricity directly without input. There is input, which is light, and light is not good quality energy, but solar electrical energy, so electrical energy is a good quality energy. So this energy, how much the consumption, how we calculate the efficiency is important element need to be cover and understand here. I will start with this example and I will clarify what I mean by this. Let's have a look at this example. He told me that in this example, find the thermal energy Q, which is needed to heat up a liter of water. I have 1 kilogram of water, and he told me I want you to heat it from 15 Celsius into 98. And consider that the heat capacity for the what, you know, any element, any material have heat capacity. Okay, it's constant. Now this heat capacity for water is given to you in this value. There is formula to calculate the heat thermal energy. Thermal energy equal heat capacity times mass times temperature difference. He gave me everything. He gave me the mass, 1 kilogram. He gave me theta 2, 98, theta 1, 15, and C, which is 4.187. I just need to multiply, just merit of math. This is, let me say, kilojoule. I will convert it into watt hour. You have the table, you can convert. It is 97. Okay, now easy. Now this 97 watt hour to heat 1 kilogram of water could be done through different sources of energy. I can heat it by electrical heater, by electrical stove, by gas, let me say cooker, but by different way. Okay, here is example of different way I heated this water. I heated this water. This gas stove, sorry, electric stove, microwave, water boiler, electric kettle. Okay, different way to heat the water to get this 97 watt hour. Now here I will compare the shadow one is energy demand in watt hour. It means to get the 97, okay, watt hour, how much energy I need by each one of these methods, this method, this method, this method, okay, to get this 97. This is called energy demand in watt hour per liter. And the unshaded one is the cost. Okay, let me talk about the shaded one. If you look here, you will see that the gas stove here have the highest energy consumption. And the lowest energy consumption is the kettle, okay, electric kettle. So here we use more energy to get 97. Here we use less energy to get 97. This is one point. Another point, if we look to the cost, we will find that gas stove is, the cost of gas stove is the lowest cost. You see here, I'm using more energy, but the cost is low. You got it? The cost doesn't mean if I use more energy, okay, the cost will be high. No. You see here, I'm using here more energy, but the cost is low. This needs to be considered. Cost is an issue here. It's not important to say only efficiency is my target. No, look also to the cost. Now, these days, when the authority of electricity and they change the prices of electricity units, okay, kilowatt hour, people start asking about solar, mainly solar. How can we install solar? Is it cost effective? Is it why? Because the cost went there. Does it mean that electricity coming from the power plants we have here in Oman, which is mainly natural gas power plants, it doesn't mean that this is the best option. Now, because of the cost, people start looking at another options. Okay. Now, still with the same example, okay, I talk about the cost, I talk about energy demand, okay. Now, you know the efficiency defined to be output over input, or very simple, profitable energy over expended energy. Now, based on this, we need to classify our efficiency based on the energy type. Is it primary energy? Is it using final energy? Is it using effective energy? Which one is used? Now, first of all, let's define each one of them. Primary energy is the original one, original energy, not yet have been treated or processed. Example, crude oil, coal, uranium. We don't, it's directly came from the source, solar energy or solar radiation. Final energy is energy in the form which that can reach the end user. As example, electricity. Electricity reaching the end user. But it is not primary energy because it's generated by something. We may burn coal, we may burn fossil fuel, we may do something to get the electricity. So we call it final energy, okay? And last is the effective energy. Effective energy is the one used by the user. As example, I use the electricity to produce light, to drive force of a machine or a vehicle in the industry, right? So when you calculate the efficiency, you need to deal with the primary energy, so your calculation will be correct. Otherwise, you will have a deviation in your results. It will not be correct. We need to deal with the primary energy. Don't jump directly from here and work with this. No, primary energy is the main. Okay, start from here. See how much it costs you until you got this. Okay. Now, still with the same example for the heating water, 1 kilogram of water. Now here I try to give example related to this, using natural gas source at home, natural gas source to heat the water to get the 97 watt hour, or I will use coal. Okay, we went out and we use coal to get the 97 watt hour. Okay, now we can see here it seemed to be for natural gas to get 100% the needed energy, which will produce 97 watt hour. I need 311 watt hour energy from natural gas, while from coal I need 3,515 watt hour. Just a minute, why they are different? Well, they are different because of the technology, because of the losses. As example, for natural gas, as you can see here, okay, 90% will be final energy, convert into final energy. We lose 10%. And this final energy, effective energy, which was the one I'm looking for, 97, okay, which is 31%, and around 60% is losses. When you cook at home on the cooker, you produce heat, but it is dissipated. Part of it will be taken by the container to cook food, right? For coal, you can see final energy is around 34. I lose 66% losses. And this one, the 34%, it come here, 19% will produce 97 watt hour, and the remaining is losses. You see? So for the same required amount of energy, you will have in the process different amount of losses, and the efficiency will be different. Now here, two important articles I published a few years back. Okay, one of them is climate change, as you can see here, climate change and game changer in the Gulf Cooperation Council. And the other one is the impact of oil price fluctuation on common renewable energy in GCC countries. It gives a good brief about information about the energy, renewable energy comparison between them, the efficiency, the cost, and the situation in the GCC countries. Okay, the 6 countries, and what happened, what is my prediction for the future, what I expect will happen in the next few, let me say, decades. I will send them on the Microsoft team later on, inshallah, today. Okay, you will find good information in this article. I advise you to read something in this article. I try to pick here few statistics from these papers. Okay, here is the world oil reservoir and the production. Okay, here is the reservoir in figure A, and in figure B is the production. Okay, see here, you can see there is Asian, Pacific, South and Central America, world Arab world, sorry, North America, Europe, non-Arab Middle East. But you can see the Arab world, okay, is producing around 40 reservoir. Their reservoir is 34%, and they produce 32% of the world. In this region, in our region, 1/3 of the world energy coming from this region. It's rich region with energy, okay, particularly fossil energy, talking about oil and gas. This is all the data talking about 2011. So there is energy, and you may ask, okay, so if we are rich and we have energy, why we are worrying about energy? Why we need to increase the cost of energy? I will tell you why. But let me continue with this. This is Arab primary energy. I mentioned here to the amount of reservoir and amount of production. But here I'm mentioning to the Arab only amount. It contains what? It contains mainly oil and gas. You can see 62%, this is in 1971, while in 2010, 51% gas increase. This tells me that there is a good production industry of natural gas in the region. Qatar is leading in this direction. Oman also have a potential. One more point I would like to add here, and then I will answer the question I just mentioned. The one I would like to add here, see here, this is around 2 decades, from 1992 to 2001 and 2002 to 2011. Here I'm trying to compare between energy consumption in some regions. CC, this is the GC regions, Iran, US, China, India, blah, blah, blah. GCC regions are the 6 countries, Kuwait, Qatar, Saudi, Kingdom of Saudi Arabia, United Arab Emirates, and Oman, Bahrain, right? Small countries, the population is small, still small, but see their energy consumption compare with India. You can now understand the comparison. Not less than 20 doubles of the population, but they consume almost the same amount of energy. What does this tell me? This tells me we have large energy consumption per person, per capita. We need to look at this. This is not good. This is not sustainable. We need to look how to reduce the energy consumption by people, by countries. Okay? And here is the answer for the previous question I mentioned. The region is rich in energy sources. Why we need to consider this? Have a look. This is the energy proved reservoir. I will not talk about the other this is more information to you to have a look at them. But here I'm looking to the reservoir. Okay, Bahrain, Kuwait, Oman, Qatar, Saudi Arabia, United Arab. You can see definitely Saudi Arabia is the highest, 265 something. Okay, BBL. Okay, billion of barrel level, I think, the abbreviation for this. You can see Kuwait coming next, 101. United Arab Emirates close to Kuwait, 98 around. But Qatar, 24, around 25. But look, Oman, 5.5. The reservoir is small. It's limited. Just a minute. Is this mean that in Oman there is no enough reservoir for oil? Until this time, we can say yes. But this is not the final answer. We need to explore to see new reservoirs if there are. The land of Oman is huge. We're talking about more than 3,000 kilometer coast. We need to look to the land, to the water, to see, do we have reservoirs? Exploration is important here. This is advice to explore our reservoirs. But this is until now the known reservoir for the fossil fuel energy. For that, we need to consider the energy seriously. Costs increase. This is expected because of the let me say global situation, economic crazy, especially from 2014 until now. I will talk about them, inshallah, in sustainability. I will stop here. This is introduction to what we are going to study, which is energy and renewable. To next hour, inshallah, this week, I will try to classify renewable energy, renewable and non-renewable, try to compare between them and to give brief about each one of them. But at the same time, I will compare between Oman and mainly United States of America, because for many reasons. I will leave this to the next hour. Do you have any question until this point? Is there any question? Are you still there?
Yes, we're here there.
Okay, did you download the material from the SULMS?
For this week, Doctor?
For module 1, I uploaded all material for module 1, week 1, 2, 3. You will find the material there, you will find the tutorial, you will find the lab sheet.
We'll download it all.
Please try to download them. If you face any problem, let me know so I can help you to solve it. If you don't have any question, have a nice day. I will see you next session. Thank you very much. Try to leave. After I leave, please try to leave so the session will be closed. See you. Bye-bye.